I want to quickly showcase a new release from NVIDIA, and it's called Llama-Mesh. Now, to put it really in simple terms, essentially what it does is it leverages a large language model, which in this case is Llama 3 8B, and allows it to produce spatial data from text inputs or vice versa. Now, I understand you'll be like, okay, but what does that mean in practice? And essentially, using that LLM, you can descriptively ask it to make an object file of, say, a wrench, and it will generate actual spatial data that can then be placed into a 3D printer slicer program, and following that onto the printer itself. So that is really going to be what I showcase in today's video. I think it is really cool to actually have that capability, even if it is early and some of the outputs are perhaps a bit not the best. But I do want to just quickly showcase the GitHub for this project. As you know, I like to cover open source things and things that those of us at home can play with ourselves sans any really extra fees. So we can see here that on GitHub, we have Llama-Mesh, unifying 3D mesh generation with language models. And there's an abstract here. It explores expanding the capabilities of large language models pre-trained on text to generate 3D meshes within a unified model. And the rest of this is perhaps a bit verbose and technical, so we can kind of just scroll beyond that. We have a method here with a complicated looking but actually kind of simple graphic. So essentially it says, Llama-Mesh unifies text and 3D mesh into a uniform format by representing the numerical values of vertex coordinates in the face definitions of a 3D mesh as plain text. The model is trained using text and 3D interleaved data in an end-to-end manner. Therefore, the model can generate both text and 3D meshes in a unified model. Now, essentially, the best way to explain this is just through this picture, where basically we can see here, okay, it has text. This is a 3D mesh of a tree. And then following the colon here would be the actual outputted value. So this, I believe, V is a vertex, and then these are some spatial coordinates, and then F would be a face. However, the nature of this essentially means that if you just put in this as the input and kind of asked it, what is this? It would say that this is a mesh, 3D mesh of a tree. So basically it's able to do both. It can do text to this spatial data, but it can also do this spatial data to text. And that's kind of just a simple way to put it. Now, unfortunately, this is a bit resource intensive to run. Now, the laptop I'm using right here has an NVIDIA 4060, but it's not really good enough to run this. So what I do have going on here is it is running in my AI LLM machine that some of you are likely familiar with. So all I will do is navigate to that. And I do believe it is port 7860 for the Gradio web interface. And I will, at the end of this video, do a quick install guide. It was actually really quite simple to get running. The script is pretty easy for someone to look over. So, and now that I'm on the website, we are met with our web interface. And again, this is running on my other machine, so you can see that I'm connected to it here in the browser. Now, the first thing we're going to do is just kind of try this. Now, people were having trouble clicking one of these and actually getting it to work. So I am actually just going to go ahead and copy paste this, and you'll have to excuse my poor ability to use the trackpad of a non-Apple laptop. So create a 3D model of a table in OBJ format, which kind of helps tell the model, okay, I want a 3D representation. So saying OBJ format helps it understand what you're actually looking for. And you'll see a bunch of things going on here. So V is vertices and F are faces, and the numbers following them are spatial coordinates. Now, I am not an expert in the mathematical things behind this and stuff like that, so this is just kind of a simple explanation in a beginner's understanding of this. And it will be generating for quite a bit. So once that concludes, which it seems to have, we can go back up here. We will copy it. We will paste it into this 3D mesh input box here. And once we have done that, we click Visualize 3D Mesh. And very well done. Truly, rather well done indeed. I am actually impressed with this. So I do want to actually 3D print something this has made, which is going to be the whole point of this video. And honestly, this looks pretty good. It's simple, I understand that, but I'm kind of cool with that. So I'm going to show you actually how we're going to do that right now. So we are simply going to search for Notepad. I think Notepad's still, okay, good, it does. Yes, thank you. All I'm going to do is paste this in, and I'm going to save it as an object file. So, table.obj, and now all I need to do is actually see where this was saved, because I don't really use Windows a lot, so I'm not very good at it. I only use this computer to play BeamNG Drive, as you can see. But I've thrown that into the slicer here, and check this out. Okay, so we have 3 non-manifold edges, which Bambu Studio actually does give us the option to repair. However, I'm probably going to pass on doing that. I'm just going to print it as is. So I'm just going to orient it in a sort of table way. We're not using the A1, we're using the A1 Mini. And I'm kind of okay with doing this a little, no, we'll do 20. 20 seems good. All right, now we're just popping this over to the printer, and I'll get a close-up on this so we can see it. Actually, no, I'm gonna keep it all going live. All right, so we have our table. It should take 53 minutes. All right, well, I guess I'll time lapse this. Okay, so I've returned, and well, I assume that the time lapse probably just showed what happened here, but I think the Bambu slicer may have had a point about layers maybe 4 through 6 being empty. Actually, this looks like it may have moved. I don't know what happened, because truth be told, I haven't watched the time lapse. But since the point of this video was to just kind of show how you can directly 3D print something this generates, I will have to say that this is a satisfactory result for my purposes. Okay, so after watching the time lapse, I realized that the issue was not in fact with this model, but may have perhaps been related to the fact that I did put this on ludicrous mode and then just left it. So this would have successfully completed this properly, and we would have had our completely AI generated table model, which I think is pretty neat. So I'm not going to print anything else for this video, but I do think it would be prudent to do a few more generations here and maybe just of some different things. So I'm back in the web interface here. And basically all I'm going to do is copy this prompt. I will delete the original conversation and start fresh. Then I will say, maybe not a table. I don't want to overwhelm it, but I also do want to use something that may kind of push its ability a bit more, if you will. Let's do of a rocket ship, sure. All right, so our rocket ship model is finished, and this really was generating for a long time, perhaps the longest time that I've seen it actually playing with this for a day or two. So we'll go here, select all, delete, and we'll paste in our rocket ship. Now, based on some playing with this, I'm not expecting anything that is really too detailed or proper here, but I'm not gonna, oh wow, okay, so from this angle, all right, well, you can see that this is a current limitation of this model, is really intricate sort of designs. So our rocket ship was sort of a disaster, so I just asked it to make a low poly computer, which it just came up with this. So you can see that this is sort of a very early demonstration of this sort of technology, and I wouldn't really expect to get anything that is very usable out of this. However, this does have some cool use cases for not even 3D printing, but like indie game development and things like that. Essentially, in the future of this technology, you will be able to describe a game asset that you'd like, and it will generate you a model of that you can then throw into your assets pane in Unity or something like that and actually use it in the game. You can just slap a texture on it from one of the built-ins or whatever, however you go about doing that. Like I said, this is an early demonstration of this sort of thing and will ultimately likely blossom into something that is far more refined than what we see here. But I think it was totally worth showcasing. And now, keeping in sort of the nature of my videos, I will just do a quick install guide for those of us who want to play with this locally. And for that, I will switch over to full screen recording on my Ubuntu machine. So I'm going to give a super quick install guide on how I got this working. It was very simple. So I did it in Conda. First thing I did is just make a generic Conda environment using Python 3.10. I then activated said environment. From within the GitHub repository here, I copied the URL and just did a git clone with this specific URL, which will go ahead and put this on your local machine. And then I find the directory it is in, which is called Llama-Mesh here. So I will head on in there. And it can be a little cumbersome to type because of the capitalization in certain parts or the other. And then you are going to want to install the requirements.txt. And make sure you are within the actual repository that this was cloned into on your local machine. Directory, excuse me. And it is using all these that are cached because I did already do this. And if you are doing this for the first time and you are going to be running this locally, what will happen is when you run the script for the first time, it will go ahead and download the model and everything here from Hugging Face. And once that's done, you'll be able to play with it. And just keep in mind that it is rather graphically intensive. So I am running 2 cards here, and it was really putting a strain on both of them. So I suppose I will show you that real quick. So we can see both cards, and when I start this, and since I have already downloaded it, it won't download the files again, it will just load them. And I'll close all this so that we can head directly to the URL once it opens. But you can see that card utilization was originally at around 3 gigabytes on card 0 here, and that was just for OBS. And some folks had actually been mentioning that if you click on these, it doesn't really quite work too well. So and you can see that as it is actually generating, it is using about 30 gigabytes across both cards. I think we can subtract 3 from this one for OBS, which is pretty intensive. That's a quick install guide for this. And you can see here that it generated the mesh. Very simple. And we'll paste it, as we already all saw. And there's our table. Well, it certainly did better the first time. And for those of us running it at home, there is something here that says, if you observe incomplete generated meshes, try to increase the maximum token length to 8,192. So we'll do that. Copy this, delete, and make note that they only support generating a single mesh per dialog round, so you can't just ask it again when it has generated it here. You need to hit this and then do it again. So as we generate it, we have set our token length to increased number, and we'll see if we get anything different. Based off of purely visual, I don't think we will have gotten a complete table, but I might be wrong. Nope. Alright, so experimental, play with it, have fun, and these are the installation instructions.